All right, here's quiz 11. A lot of people have asked for feedback, and so I'm going to go through what I was looking for and what I was expecting, and so maybe from that you'll be able to figure out what my comments were. So, okay, so we're given the integral y equals 0 to 3. X goes from 0 to 9 minus y squared. And z goes from 0 to 18 minus x squared minus y squared dz dx dy. All right, now, so part one is to sketch this thing. And I've been harping all semester about how important these sketches are, and in this case, it was everything, right? Trying to unravel what this thing looks like. This is a volume problem. What this thing looks like, which for the spherical coordinates was key, because for the cylindrical it was easy. You could just change the boundaries and integrate, but for the spherical it turned out to be a disaster. So here we go. Here's the sketch. Y, x, z. So z runs from 0 to the sphere x squared plus y squared plus z squared equals 18, right? So up here we have root 18, and the sphere is opening down. Now r, cap r, is encoded in this. So x is positive and y is positive for in quadrant 1, and we're on the circle. We're on the circle x squared plus y squared equals 9. So this is cap r. Now, a lot of you just said, okay, this thing opens down like that, and that's it. Well, that's not it. These two don't intersect on the xy plane. They intersect somewhere else. And you need to find that. Okay? You need to find that. So here we go. I'll put the root 18 up here. So we have the sphere. Let's just do it like this. Z equals 18 minus x squared plus y squared. And down below here we have that equals 9. So that's 3. So at z equals 3, the cylinder x squared plus y squared equals 9 intersects the sphere. So that's the shape you want. Okay, and even add all these numbers in here. So this length is 3. That's 3. So this is 3, 3, and just like the workshop on Friday, this is the line y equals x, and this is pi over 4. That helps. Okay, so there's the sketch. That was worth 1 point. A lot of you did 0 to 2 pi and all that kind of stuff. So 2. Convert this to cylindrical coordinates. This piece is worth 3 points, right? And I was shocked at how few people did this, because I've been all geeked out about it all term. But this whole idea of, running array from the Southland M up through this thing. I've talked about entrance wounds and exit wounds and all that kind of stuff, but I didn't see ray M for a lot of you. That gives you your z bounds. So z goes from 0 to 18 minus r squared. Oops. That's supposed to be dz. Right? So coming from the Southland, we go, I intercept r at 0, z equals 0, and then I exit up here and x squared plus y squared is r squared. So that's our first bound. Now we look at the circle, quarter circle, cap r. And little r goes from 0 to 3. And theta goes from 0 to pi over 2. Okay. So that was the volume in cylindrical coordinates. All right, the next bit, was the crux. So 3. So we're on a sphere, but we're also on a cylinder. And Friday's workshop had a problem too called sphere versus cylinder. And this was sort of supposed to motivate you for this problem. I said this will be on there, and there it is. Okay, so because I want to do this all at once, I'm going to redraw the picture. With all the relative details there. 3, 3, 3. Like that. Okay. All right. So now we're doing spherical. Now, when you do spherical coordinates, what do? I love this word. We emanate a ray out from the origin to the shape. So maybe I should do that, right? And here's where rho goes from 0 to the cylinder, right, on this bottom half. Phi goes from pi over 4 to pi over 2, and theta goes from 0 to pi over 2. That gives you this volume. What about this volume? We'll use a different color here. Now you emanate a ray out and it intersects here. So now you have a different volume. So rho goes from 0 to root 18 because you're on a sphere. Phi goes from 0 to pi over 4. And theta goes from 0 to pi over 2. So we still need to find the second row bound here, this one here. And we did this on Friday. It turns out to be 3 cosecant phi. And then you put in your differential here. And you add these together, and that gives you your volume. Okay? And this guy was worth 4 points because there's 2 integrals and 2 sets of bounds. So now we're up to 4, 5, 6, 8 points. Okay? And now part 3 is to evaluate. And I mean, if it isn't clearer than clear, evaluating cylindrical is significantly easier than spherical. So let's do that. Theta goes from 0 to pi over 2. R goes from 0 to 3. C goes from 0 to 18 equals r squared. dz r dr d theta. Okay. So now you integrate. And you get r 18 minus r squared dr d theta. Okay. I changed this problem to make this happen so that you didn't have to do a trig substitution anywhere. So now you let u be 18 minus r squared. du is minus 2r dr. So you get u goes from 18 to 9. U to the 1/2 du with the minus 1/2 out front d theta. And that's just a case you're wondering, that's just a stray mark. Not another negative. Okay, so now we flippity flop. Alright, just plowing this thing out here. This takes time, but it's not bad. You have 1/2 times 2/3 u to the 3/2, and u goes from 0 to 18 d theta. So now you get theta equals pi over 2. 2's cancel, you get 1/3. Hold on. You get 1/3. You get 1/3. (18 to the 3/2 minus 1/3, 9 to the 3/2. Hold on a second here. This is an awful number. But what did I put at the beginning of the quiz? At the beginning of the quiz, did I put it up here? No, but on the quiz it's there. There's a big hint. It's in bold. It says 18 to the 3/2 over 3 is approximately 25. Because all of you pissed and moaned about how hard working with this same number was on Friday, I said, oh, let me just give you the approximation as an integer, because we know I love integers, and replace it with that, because this is just, it's a volume. So, and then 9 to the 3/2 is 27. 27 divided by 3 is 9. Okay, so now you get theta equals 0 to pi over 2, 16 d theta, which is 8 pi. Just a lovely number. And so evaluation was worth 2 points. All right. Well, what can I say? This was a 20-minute quiz. One brief question based on all the problems we did from homework and the entire workshop from Friday. If we were in class, I would give you 20 minutes. I'd pull your papers at 20 and be over. Which means in COVID times, it's a 30-minute quiz. Because I give 10 minutes for you to take a photo and upload it, which is, on a good day, takes 30 seconds, and on a bad takes 5. So there's leeway in time. What did I give you? I gave you 40 minutes. Now, apparently it didn't show up until 3 minutes after 8 or 6 minutes after me, whatever. Whatever it was less than or equal to 6 minutes. And so with the 10 minutes there, I know, okay, so all the ones that came in late, did I dock you points? No, I didn't. And I felt that this was significantly easier than Friday's workshop, significantly easier than the homework, and significantly easier than last week's quiz, which was a proper 50-minute quiz. It took me 6 hours to grade, and I was trying to get away from that. So for those of you who are upset with your grade, I don't know what to tell you, but I feel in my heart of hearts, knowing what we've done, that this was a fair quiz, and I gave as many hints as I could in as much time as I possibly could. So there you have it.